This week we are looking at the ear and how it captures sounds. So looking at this poster, the big earlobe is sort of structured so that it traps or it can collect the sounds effectively. The sound waves then go down through the ear canal until they hit the eardrum. The eardrum vibrates and makes these three tiny little bones, the hammer, the anvil and the stirrup, vibrate. Those vibrations that get transferred into the cochlea. Inside the cochlea are the tiny little hair cells which vibrate and send electrical signals down this nerve all the way to the brain so that the brain can interpret what we're hearing. This is a picture of the hair cells found in the cochlea. The hair cells are quite sensitive. Each hair cell picks up a certain vibration, and if the sounds that you're hearing are quite loud, you can damage these hair cells, and once they are damaged, you will no longer be able to hear at that frequency. It seems that the higher frequencies, such as 20,000 hertz, those hair cells get damaged more easily than the lower frequency hair cells. What you're seeing here is a simulation of how the eardrum works. The plastic wrap represents the eardrums. The rice shows how the eardrum is vibrating, and if you get a tuning fork and hit it, the vibrations, and hit it and place it above the eardrum, the vibrations go through the air and make the eardrum vibrate, and you can see the vibrations by the rice moving. This is a decibel meter, and you can see I'm talking into it now, so the decibels recorded are about, in the 60s. So that's a typical sort of decibel sound for conversation. I'm now going to shout, and you'll see what level the decibel meter goes up to. Ah! So 119, that's pretty high. At 120 decibels, your ear starts to be painful, so you shouldn't be shouting into anybody's ear. This is a model of the ear, blown up, quite big. As you can see here, we have the eardrum. We have the three tiniest bones in the body, the hammer, the anvil, and the stirrup. Then here is the cochlea. This is the nerve that goes off to the brain so we can interpret the sounds. Also, this tube here is the eustachian tube. It goes to the back of the throat. And when you're in an aeroplane, to equalize the pressure in your ears, you swallow. So this is here so that we can make sure that the pressure in our ear is the same as the pressure outside. Model of the ear.